Have a good day. I welcome you all for the introduction about the open elective offered by the E&A department. The open elective is Smart Sensor Technology. The course coordinator is Dr. S. Antoni Jesudure. The email ID is jesu.com@mcd.in and the contact number is 9944710808. Smart Sensor Technology. Simply we can call it as SST. What are you going to get after learning this subject? So that is the course outcomes. It has nearly 5 course outcomes. The first one is explicate the structure of smart sensors and build the sensor. The second one is describe the data association from sensor to other devices. And the third one is summarize the various communication protocols used for data processing. Fourth one is elucidate wireless technology used in smart system, sensor system. And fifth one is explain the sensors used in various smart devices that includes mobile phones, automobile, and wearable devices. Here, the reference book that is Understanding Smart Sensors by Randy Frank that will be referred. It is one of the reference and textbook to learn this course. Smart sensor. Before moving to what is smart sensor, let us see what is sensor. Sensor is a device that measures a physical quantity and converts into a signal, that is electric signal, which can be read by an instrument. So any measurement device or any automated device which is going to control automatically certain tasks without sensor, we cannot measure the physical parameter and control the particular parameter. Let us see the air conditioner which has a thermal sensor, that is temperature sensor. It measures the room temperature. It depends upon the set point. For example, if I want to keep my AC temperature is 20 degrees Celsius, then first the sensor has to check what is the current temperature or the room temperature. Next, depends upon the temperature and the set point, it's going to takes necessary action and control the temperature, that is the room temperature. So the sensor is very important for any kind of sectors. Coming to smart sensor, it is like an intelligent sensor which is going to not only measure the parameter and also it has an inbuilt with memory and there is a controller. The sensor itself is going to take certain action to control the parameter. Smart sensors are defined by the IEEE 1451 standard as sensors with small memory and standardized physical connections to enable the communication with the processor and data network. So it is an intelligent sensor which has memory, processor, and certain communication, particular protocol which is inbuilt with that sensor. It sends the data from one device to another device. For example, and today we can able to see the parameter which we are going to measure. We can able to see through our phones as well as tablets or computer, and remotely we can able to monitor and control the certain parameters. And today's technologies, if you find in all the sectors without sensor, we cannot monitor any parameter. Also, we cannot control certain tasks. So the sensors are very important. And if you compare with the smart sensor has an IoT supported things and also it has an intelligence. When a sensor becomes a smart sensor, it enhances the some of the applications. Let us see one by one. The first one is self-calibration, means it adjusts the deviation output of the sensor. And the next one is communication. It sends the data, broadcasts the data about its status to the remote site. The next one is cloud support. So it provides big data analytics, and machine learning algorithms. And the next one is computation. It allows one to obtain the average, variance, and standard deviation of the set of measurements. The next one is multi-sensing. A sensor can able to measure a single parameter, but a single smart sensor can able to measure multiple parameters such as pressure, temperature, humidity, gas flow, and infrared, chemical reaction, surface distance, acoustic, vapor, and etc. And very important thing is cost effective. It has less hardware and reduction of repetitive tests make smart sensors that becoming cost effective. In any measuring system or any kind of device that going to measure or sense any parameter, the basic thing is sensing element. This is the first one, that is the sensing element. So from this only the physical parameter is measured, and next it is given to the data conversion element, and the required data will be get it through this data conversion element and given to the data manipulation element. The manipulation element, what it does, it manipulates the physical parameter and send it to the data transmission element. Here through some communication medium, the data will be transmitted and that will be presented to the end user through the data presentation element. So this is the structure of a measuring system. So any measuring system, the basic element is sensing system or sensing element. For example, you can see that here there is a digital temperature measuring device. So in this COVID situation, you can find this type of devices are used in most of the places to check the body temperature. So here, the first and foremost thing is a sensor, a thermal sensor, which is placed in front of that device. So it is a IR based. So depends upon the temperature, the wavelength will be changed or converted. So that is taken into the account. So the data will be converted into electrical signal. That is the data conversion element, and it is taken in the particular format that is called manipulation element, and it shows the temperature as a in electrical format that is converted into a digital signal that you can see on the display. And later on this can be uh, visualized or this can be measured through even IoT based systems, or even you can see the smartphones or tablet. So this is the best example for smart sensing device. So the objective of the course is explain the structure of smart sensor, describe the data acquisition through the sensor, summarize the various communication protocols used for data processing, and elucidate wireless technology used in sensor system, and provide knowledge on inbuilt sensors in smart devices. In this subject, the course contents are: the first unit is introduction to smart sensor. So here, how the sensor will become a smart sensor, and what are the hardware is required to become or to get it as smart sensor. And particularly we are going to learn about the IEEE 1451 standards. And the second unit is data acquisition through the sensor. How the sensor is going to send the data to the next device. For that, what are things is required? If you look into the sensor, it provides a information about analog signal that should be converted into a required level using the signal conditioning. Next, using microcontrollers and some other digital devices are integrated with that to get the data to the next level or to send to the next device. So that is unit 2. And unit 3 is communication for smart sensor. That is very, very important. So it sends the data from one device to another device in the sense it requires a communication. It is a wired communication. Here it is, there are different type of protocols are incorporated and that we are going to learn in this unit. So there is a different type of protocols, particularly BOS has developed a CAN protocol, controller area network, that is widely used in automotive sectors and all sectors that we are going to study in unit 3. And unit 4 about wireless sensing, how the data has to send to in wireless medium. What are the different type of technologies are used in wireless medium that we are going to learn in unit 4. The unit 5 about case studies. Here we are going to learn the three different smart devices. One is mobile phone, another one is automotive sectors, particularly vehicles, and third one is wearable devices. Today you can see the smartphone has a lot of sensors inbuilt that we are going to learn in this unit. And the next one is you can find there are a lot of sensors are connected in the cars. So the automotive vehicle has a lot of sensors. Without sensor, even today we cannot run the car or the vehicles. And the last one is wearable devices. You can see the MI band and another other different devices and all. Wearable devices has different type sensor that going to tell about the status about our body condition, particularly temperature, BMI and all. So these are the three different smart devices that we are going to learn in this unit 5.
Self-driving cars are now a reality. Take a look around. Cars are already driving themselves on the roads of California, Texas, Arizona, Washington, Pennsylvania, Michigan, and many other cities. Though currently, they are restricted to specific test areas and driving conditions. But how exactly do they work? Just like humans, they also face issues of traffic congestion, rash driving, potholes, trees, and other obstacles on the road. But again, how do they change lanes, keep a safe distance from other vehicles passing by, and how do they identify roadblocks? Let's take a closer look at how they handle such situations smoothly. You might have noticed a rotating device installed on top of this autonomous vehicle. Sometimes these devices are mounted on the bonnet. This device is called LiDAR. It acts as the eye of the self-driving vehicle, providing a 360-degree view of its surroundings in order to enable safe driving. Continuously rotating LiDAR system sends thousands of laser pulses every second. These pulses collide with the various objects around the vehicle and reflect back the signals. These light reflections are then used to create a 3D point cloud. An onboard computer records each laser's reflection point and translates this rapidly updating point cloud into an animated 3D representation. The 3D representation is created by measuring the speed of light and the distance covered by it, which helps to determine the vehicle's position with respect to the objects surrounding it. The 3D representation also monitors the distance between the vehicles that pass by and any other vehicle in front. It also helps to command the brakes in order to slow down or stop the vehicle. When the road ahead is clear, it can also allow the vehicle to speed up. LiDAR is also being incorporated into another development called pre-scan. In pre-scan, laser scans the road surface several hundred times a second. This information is then fed to the car's onboard computer and processed in a fraction of a second, which adjusts the individual suspension for each wheel of the vehicle. With this, autonomous cars achieve the smoothest and safest ride possible. The technology helps wheels and tires avoid imperfections on the road surface and warns the vehicle about obstacles and potholes so that they can provide bump-free rides to their passengers.
smart sensor technology, the need of today. Thank you so much for watching.